Hello friends, welcome to our channel study guide. As you know friends, we are solving the electrical objective question paper from SSC JE 2018 of 23rd of January 2018 and second shift. We have already completed our fourth shift and this is our fifth session of this shift. Okay, so let us see what are the questions of this session. So friends, we are very interested about the 1200 question because there are the 12 sets and 12 sets means 12 into 100, there is 1200 question electrical objective question, and we are very interested to solve these 1200 objective electrical questions. Okay, so first let us solve and then we will tell you the strategy, preparation strategy of the examination. Okay, so first, what is the first question of this session? The first question says that determine the value of the produced MMF in ampere turns in a coil if the coil has 120 turns and carrying a current of 0.1 ampere. Okay, so what is the MMF? MMF is the ampere into turns. MMF is the ampere into turns. Now what is the ampere? Ampere is already given. Okay, your answer is already given in your question. This is ampere into turns. Okay, so MMF is equals to ampere into turns. Ampere into turns. Ampere means 0.1, turns means 120. Already given turns is 120. Okay, so ultimately the output will be 12 ampere turns. So ultimately output will be 12 ampere turns. Okay, so next question. Next question, what is said? Next question said that what will be the magnetic field strength? Okay, magnetic field strength in ampere per meter. Okay, ampere per meter of a material when the intensity of the magnetization of a material is 0.064 ampere per meter and the magnetic susceptibility of the material is 0.52 into 10 to the power minus 4. Okay, now what happens? That what is the definition of the magnetic field strength? Magnetic field strength can be found by dividing the magnetic intensity of magnetization divided by the magnetic susceptibility. Now if I divide it, no calculator in the examination, so 0.064 ampere per meter divided by 0.52 into 10 to the power minus 4. Okay, now so 10 to the power minus 4, if I take it to the numerator, then what will happen? 0.064 divided by 0.52 into 10 to the power 4. To the power 4. Okay, now if I multiply the numerator and the denominator to eliminate this point, okay, by 1000. Okay, I divide it by the 1000. Okay, so 1 0 comes here. This 0 will eliminate the 10 to the power 4 to 10 to the power cube. Okay, this 0 will eliminate to 10 to the power cube. Now if I divide it by 2, 32, divided by 2, 26, divided by 2, 16, and divided by 2, 13. Okay, so what is the ultimate output? Ultimate output is a 16,000 divided by 13. Okay, so it can be done simply. Okay, no calculator required. It can be done simply. So 16 divided by 13, there is 1. 13 into 1, 13, 30. So 30 means 13 into 2. 13 into 2, 26, 40, 3 into 13, that is 39. Now 10 will not divide, so 0. So then 100, so it will become 7. Okay, 7 into 13, 91. So the answer will be 1230.7. So the nearest option is the option number 4. Nearest option is the option number 4. Okay, so I hope these problems are very simple and can be done without any calculator. Okay, so moving to our next question. Very tricky one, this next question. Then next question have some concept of the magnetic field. Okay, Now the question said that determine the magnitude of EMF in voltage induced between the axis of the rotation and the rim of the disc. Okay, when the disc of the radius 10 centimeter, okay, the disc have a radius of 10 centimeter, rotates with the angular velocity. The velocity is already given in the angular velocity of 60 revolutions per second and placed in a magnetic field of 3 Tesla, acting parallel to the rotation of the disc. Okay, so what will happen? So first let me draw the disc. Okay, this is the radius and this is the diameter. Okay, what is the induced EMF? Formula for the induced EMF? The formula for the induced EMF equals to BLV. Okay, what is the B? What is the B? B is the flux density. What is the flux density? Flux density is already given 3 Tesla. Flux density already given 3 Tesla. What is the length given? Okay, length will not be the radius. Length will be the total diameter. Okay, what is the diameter? Diameter is 20. Diameter is 20. So 20. Now 20 centimeter. So if I have to convert it into the meter, so if I want to convert it into the meter, so that means 20 divided by 100. Now V, what is a V? V here is a linear velocity, but in our question the velocity is given in the revolutions per second, that means in the angular velocity. Now if I want to convert the angular velocity to velocity, what I have to do, I have to do the 60 divided by 2 pi. Okay, 60 divided by 2 pi, that is my linear velocity. Now if I want to eliminate this 0 cancelled, this 0 cancelled, okay, this 2 cancelled, so ultimately 6 into 3, that is 18. Okay, 18 divided by pi means 3.14. okay, 3.14. okay, if it is 3.14, that means 3 into 6, 18. Now it will be smaller, less than 6. Okay, so correct answer will be option 4, though the options are very nearby, but if your observation is very clear, okay, your vision is very clear, so you can easily see that my answer will be 5.65. okay, later you can do it in the calculator, but it will not never be greater than 6. okay, 3 into 6 already 18, already the denominator is 3.14, so it must be less than, just less than 6, just less than 6. Only one options are there, that is option number 4. So option number 4 will be the correct answer. Okay, so next, move to the next question. What will be the value of current in ampere in a 50 centimeter long air core solenoid if the value of the magnetic field at the center of the solenoid is 5 millitesla? Okay, and the solenoid has 300 turns. Okay, now B is, what is the formula for B? B is mu naught Ni by L. Okay, so here we have to use some eraser due to the digital pen. So what is B? B is the flux density. What is mu naught? Permeability of the free space. That is value already given, 4.10⁻⁷. It is already been given in the question paper itself. Now what is the N? N is the number of turns. Okay, and what is the I? I is the current which we have to calculate, and L is the length. Okay, now let us write this all the values. 5 into 10⁻⁻3. Okay, what is the value of the mu naught? Mu naught is 4 pi into 10⁻⁷. Okay, now what is the N? N is the number of turns. It is already given, 300. Okay, 300 I means current, and it is not given, so we have to find the I. and divided by L. Length, what is the length? Length is 550 centimeter. So we have to convert it into the meter. Okay, we have to convert it into the meter. So 50 into 10 to the power minus 2 meter. Okay, 50 into 10 to the power minus 2 meter. Now, so there is 10 to the power minus 2. If it goes to the numerator, that is 10 to the power square. Okay, so there is will be 10 to the power 4, 10 to the power minus 7, and 10 to the power 4. So I eliminate this 0, this eliminate the 10 to the power minus 2. Okay, it will eliminate 10 to the power minus 3. Now this 10 to the power minus 3 and 10 to the power minus 3 will eliminate. Okay, so very simple calculation. So what will be the remaining I will be 50 into 5. Okay, 5 into 50, 5 into 50 divided by 4 pi into 3. 4 pi into 3. 4 pi into 3 means 12 pi. Okay, so what is the 5 into 50 means 250. Okay, and 12 pi means what is pi? Pi means 3.14. 3.14 into 12 means around 40. Okay, around 40, not exact 40, 40. So 250 divided by 40 is around 6.63. Around 6.63. How can we calculate that 6. See, it will be slightly larger than 6. Okay, slightly larger than 6, not too much larger than 6. Okay, 250 divided by 40 is slightly larger than 6, and you can, if you observe the options, okay, if you observe the options, okay, then what we will see? We will see that this only one close answer, that is option number 1. The only close answer is option number 1. Okay, later you can see it by the calculator, that is, it will be something not 6 point exactly 63, it will somewhat less or greater, but in your exam hall without a calculator, this is the most easiest trick. Okay, so move to our last question. Okay, this is our last question of this session. This is our last question. Now the question said, determine the maximum flux density in Tesla of a material having eddy current coefficient of 2, thickness of 4 mm, volume of 20 cubic meter, which is supplied by a frequency of 50 Hz when the material has eddy current loss of 66 watt. Okay, eddy current loss of 6 watt. So what is the formula for the eddy current loss? You already know. I'm just writing the formula. Formula is eddy current loss K coefficient multiplied by Bm square, flux density square, multiplied by T square, multiplied by F square, and volume. Okay, volume. So this is the formula. So already what we have given, 6 is given, eddy current loss, coefficient, that is 2, already given in our question paper. What is the Bm square? Bm square is the we don't know Bm square, we have to calculate the Bm square. T is the thickness. Thickness is 4 mm. So 4 mm means 4 into 10 to the power minus 3 meter. Okay, we have to convert all these things into meter. So square. Now into frequency square, that is 50 square. Okay, so we can write it. Okay, let us write in another way. 50 into 50, we can write 50 square into 50 into 50. Very simple thing. Okay, why I write it in the 50 into 50 format? Because later this will help me to solve the problem. Okay, so 50 into 20. Okay, 50 into 20. Now this is 6. Now how can I easily solve it? 2, 6, that will be 3. Now 50 into 20 will be 1000. 50 into 20 will be 1000. Okay, 10 to the power cube. Okay, 10 to the power cube. Here 10 to the power minus 6, here 10 to the power cube. That means only 10 to the power cube will remain. Only 10 to the power cube will remain. Now what is the Bm square? Let me find the Bm square. Okay, what is the bm square? The bm square will be 3 divided by 4 square, that is 16. Okay, only 10 to the power minus 3 will remain, because other 10 to the power minus 3 will cancel with the 15 to 20, and there will be only 150. Okay, so we have completed the calculations here, and this calculation is very much simple, and you can do it without the calculator. Okay, so now what will happen? 5 into 16, how much? 5 into 16, 80. Okay, 3, 10 to the power minus 3, if it goes to the numerator, it will be 10 cube, that is 3000. Okay, it will be 3000. Okay, let me erase this, all this once again. So what is the problem? And now 5 into 60, that is 80, and 0, 800. Okay, so if I eliminate this 20, this is eliminated. So 30 by 8 will be 3.75. Okay, 3.75. Now bm square is 3.75. Okay, now coming to the options. Okay, root over of 3.75, it is very difficult to calculate the root over of 3.75 without the calculator. But if I look at the option, okay, 2.24, 22 square, 22 into 22 is around 441, around 440. 3.3, that means greater than 9. 1.9, that is very close to 337. 19 square of the 19 is close to 37. Okay, you have to calculate. 12 square is 144. Okay, so 144. So looking at the option, what is the nearest option? Nearest option is 1.94, and it will be the correct answer given by the Staff Selection Commission. Okay, I hope you have watched our video thoroughly, and if you like our video, please share us among your friends. And if you are watching our video and you haven't subscribed our channel, please subscribe to our channel for latest updates, and thank you.